All right then, folks. Good morning. Sorry I can't be there with you today, but thank you very much for coming in. Um, I'm basically this lesson is going to be part of two different parts. The first part is me going through the lesson online, and this is what we're going to have for the next couple of weeks. I'm going to go through the slides and give you as best a description as I can the way I do it, and then an opportunity to do some of the tasks that we have to in that sheet. And if we get through it quickly, which I think we will, then there's an Oak Academy lesson for you to look at too. Now, you might be doing some of the same stuff as you go back to look at the Oak Academy lesson. That's perfectly fine. The more we repeat this stuff, the better we're going to get at it. So, hopefully, or you might not yet have done by now, but make sure that your name is on the front of the envelope that I've given you, and that all the sheets or resources that you use in today's lesson go into that envelope, and then go back to the teacher who's in there with you today, so that I can have a look at it when I get back. If you've got any questions, you can email me, and I'll get back to you as soon as I possibly can. So, energy, changing stores. What we see here is a nice little GIF of a waterfall, and we have water at the top of this waterfall that is, funnily enough, but falling down from the top of the waterfall to the bottom of the waterfall. And this sentence here really sums up what we're going to be looking at in today's lesson, and probably for the next couple of weeks. The energy store in the water allows the force of gravity to pull it down. We'll come on to this question in just a little second, but this question, even if we don't understand, or this statement, pardon me, even if we don't understand, you will by the end of this lesson, and if not by the end of this, then by next lessons for sure. A quick recap from key stage 3, though. Energy stores measured in joules are the physicists' way of being able to describe when work can get done. So energy allows work to happen. You can't hold energy in your hand. Energy is what allows work to be done. So let's think about a force moving something. So if I have a box and I move that box for 10 meters, and the box is now in a new position, a new area, then I have done work to make it move from position A to position B. And if I had a ball and the ball dropped from position C to down to position B, then gravity would have done work against the ball or with the ball. Work is when something is done. Now, energy comes in different types. So the energy that would have been in this, where I was pushing this box, so there's a person there and they're pushing that box, the energy that would be in this person would have been different to the energy that is being used to allow this ball to drop. And those different types of energy will determine what kind of work can get done on the objects. So we'll have a quick look at them in just a second. We'll have a look at all the different types, but for now we just have to know that energy stores allow work to happen. And the other question that we're going to be looking at is, if you moved it back to the top of the waterfall, would it have lost any energy? If you moved the water from the top of the waterfall, it fell from the top of the waterfall back to the top of the waterfall, would it have lost any energy? So these two sentences are what we're going to be looking at. For now, though, you can probably make a little note, please, in your progress maps, just circles around the numbers for the questions we're doing. Have a read of them. Any words you don't understand, underline them, circle them. We may not go through them right now, but if there's anything in particular you don't understand, underline them. Just in the ones that are highlighted. Just ones that might be done for you. And pause me now for them to do that. Actually, no, just let them do that, I suppose. Okay, if you need a few minutes, you can pause, but I'm gonna move on. So, describe the changes involved in the way energy is stored when systems change. Now, a system is just a physicist's word for objects interacting with each other. So describing the changes involved in the way energy is stored, just talking about how does something happen? And when it does happen, can we explain why that happens? These are the stores of energy. The most common ones are chemical, gravity, kinetic, and thermal. You should remember these from Key Stage 3. And it'll be in your knowledge organizer as well. If you look at if this is your knowledge organizer at the top left-hand corner, it should be written up here somewhere. Always refer to that if we're asking questions or if I'm asking questions. Chemical can be found in food and fuel. Gravity is it's gravitational potential energy, which is found just when you've got any object that's above the ground. You have kinetic energy in objects that are moving, and thermal energy in any object that's warm. You can also get elastic potential, vibration, nuclear, and electric-magnetic stores. But the most common ones are the ones up here. So if I had a hot cup of tea that was falling from the sky and it was falling down, it would have a thermal store, because a thermal energy store, because it's warm, and it will also have a gravitational potential energy store because it's high above the ground and it's falling. Here's the ground. So if we're describing the changes involved in the way energy is stored when systems change, well, what we're talking about here is this hot cup of tea that is really drawn very, very well has got thermal energy inside, TE thermal energy. But it's not the thermal energy inside the cup of tea that is being used to pull that hot cup of tea down. It's the gravitational potential energy of the hot cup of tea that allows it to fall towards the ground. So the way we describe this is that the gravitational potential energy store is being transferred or used or processed or shifted to do work. And that work is gravity pulling the cup of tea down. The hot cup of tea, as it's falling through the sky, will also be releasing energy into the environment. And when we say the environment, I mean just anything around the hot cup of tea. And that's going to be through another process or pathway, another form of energy transfer. That'll be heating. So basically, mechanical working, electrical working, and heating, they're the three things that can change energy stores that allow things to happen. Now, bearing in mind that we'll do the hot cup of tea again, just because I think you can probably tell I'd like a hot cup of tea. As my hot cup of tea is falling down towards the ground, the falling is the action. The falling is being done by, in inverted commas, by gravity. That's an action. It's something that's actually happening. Any object that is high above the ground will have gravitational potential energy. That can be used for the action of falling. Any object with chemical energy can be used to have a burning fuel, like if it's a fuel, it can be used to burn, to make something hot, or it can be used as a fuel for an engine. It can be used as a fuel for your body. Gravitational potential energy can be used to make objects fall. Kinetic energy is used in moving objects to keep them moving. Thermal energy is used to make things warm. But they don't actually do anything. Stores allow work to be done, whereas the processes and pathways actually do the work. So mechanical working or forces, and electrical working or charge. These two forms of work, we've already done about this. We know about that. Electrons move through wires, transfer energy from source of potential difference to components. And we know about heating and all the others as well from Key Stage 3, and a little bit about irradiation from your lessons with Miss Jones. These are actions. Actions actually do stuff. Now, drawing a hot cup of tea is a difficult thing to do, obviously, because you know that you can get that. And actually, you know, that's not too bad this time. Okay, so if I wanted to draw a diagram for how my hot cup of tea releases energy into the environment, I could do something like this. Let's say that there's radiation of heat. And I could label the hot cup of tea as having a thermal store. And I could say then that there's air around the hot cup of tea, so that there's now an increase in the thermal store in air. But that's complicated, and if you're not good at art, then it doesn't look very good. It doesn't look very easy. So instead, what we do is we draw simple boxes. So I'm going to label this box as cup of tea. I'm going to label this box as the environment. If any of you ever draw diagrams as bad as this, I'd be very upset. Now, inside the boxes, we're going to write the stores. What kind of energy stores are going to be used to make something happen? And the action that's happening up now is the heating up of air from the tea. So I've got my tool, I've got my system, I've got my cup of tea, I've got my environment, I've got the surroundings, I've got the air that's all around the cup of tea. And I've got my two stores, because energy is always going to be transferred from one store into another. But what kind of store is inside my hot cup of tea? It's a thermal store. And it's going to be transferring through heating energy. It's going to be transferring energy by heating into the environment. So what's the store that's going to increase in the environment? It's also thermal. So we've identified the store that's important, we've identified the transfer, the work that's being done, and we've identified the second store as well. Let's do a couple of examples of those. We're going to do let's do a candle burning. First off, so have a think about what kind of store there's going to be in the candle that allows it to burn, and what will the effect be of that burning on the store of energy inside of it. So the first thing I'm going to do is start off with a store. I'm going to label it as candle. And then you're going to think to yourself, right, what kind of energy is going to be inside this candle? Is it gravitational? No. Is it kinetic? No, it's not moving. Is it thermal? No, because it's not hot yet. Now, is there a food or a fuel involved in this candle? Yes, it's a fuel. So we're going to say that it's chemical energy. Now, that chemical energy is going to be transferred by a process or a pathway or a transfer by heating, because it's going to be, burning, into where? Where is going to get warm because of my burning candle? Well, the surroundings, the environment, the air. And what kind of store is going to increase when heating happens? It's going to be thermal. And that describes as candle burning. The chemical store is being turned, it's being transferred through heating into a thermal store in the environment. This is why a candle feels warm. The energy store is being transferred by heating. It makes you feel hot because if there's a thermal store in the surroundings and you are in the surroundings, the thermal store will transfer by heating energy into your thermal store. The hot air around you is going to make you feel warm. How about a car driving on a road? What kind of store will there be in the car engine? Well, it's a food or a fuel. It's kinetic. It's not moving yet. It's not going anything yet. It might be shuttling about the place. There might be pistons firing and whatnot. But what's the source of all that energy? It's going to be the fuel, the diesel, the petrol, whatever it is that you put in the car. So you can have a chemical store inside your engine. And what's going to cause the fuel that's in that engine to be turned into motion of the car? Well, what are our pathways? We've got working, electrical work, heating. Heating is going to be important, but it's the forces, it's the engine itself twisting about the place that's being fueled by the petrol that is going to make the car move. So in here, we can just write down forces. The forces are going to transfer energy. It'll be friction, it'll be push force, torque, pull, all sorts of forces moving in there. You could also say mechanical work, which just means that a force is doing something cool. The forces are making the chemical store in the engine turn into a store of energy in the car when it's moving. And that means it's going to be turned into a kinetic store. Let's think about a ball falling. I'm going to do this one fast. See if you can, in your own brain, or out loud if you'd like. No, don't do it out loud because you're listening like good people. The ball falling will have, oh, hang on, I did the wrong thing there. I'm just going to label this as the ball. The ball falling will have gravitational potential energy because it's up high along the ground. Forces are going to transfer energy from the gravitational potential energy of the ball to a kinetic energy store in the ball because it's moving. Let's think of another example. Okay, so there's a light bulb. Electrical energy, electrical work is going to be transferring energy into my light bulb. My light bulb is going to get warm, so it's going to have a thermal store. And that thermal store is going to cause the air to be heated. So there'll be a heating of the air, increasing its thermal store. Let's have another example. A cheese rolling down a hill, which is a bonus content video for when I get back. You can ask me to show you this video of a whole village full of people chasing cheese down a hill. So the cheese is rolling down the hill. What kind of store is there in the cheese at the start of this scenario? Gravitational potential energy. And that will be transferred through forces, gravity, into another store in the cheese. The cheese is moving, so that store is going to be kinetic energy. If I then put the cheese into an oven, there will be a thermal store, chemical store in the oven, a food or a fuel that is making the oven move, that will transfer by heating food to the cheese. It can be transferred by heating energy to the cheese, so it increases its thermal store. Let's think of an example of somebody walking up some stairs. So if they're walking up the stairs, then there's going to be a person, we'll say you, will have chemical energy in your leg. The chemical energy in your leg and the muscles of your leg are going to be used by forces to make you increase your gravitational potential energy because you're going to be going up higher. At the same time, it's also going to be transferring by forces kinetic energy to you because you're going to be moving. And also a little bit of heat because you're going to get warmer, aren't you? The more you move around, the warmer you get. So the chemical energy in your legs is going to be transferred into a thermal store in you, and you're going to increase your temperature. There are 3 examples here that I would like you to go for and have a go at. This is a chemical store. I just told you the answer. This is where I'd like you to write down the energy store, please. Here are where we have transfers. And anything in brackets is the object that we're talking about. This is the scenario: circuit with a battery and bulb, electrical car accelerating, an electrical motor and winch lifting a weight at a constant speed. And these are the 3 scenarios, and they are the diagrams that I'd like you to fill in. Remember, you can only put stores here. You can only put transfers on the arrows. Okay. 5 minutes for that, and if you're done, you can carry on to the next task. If you just pause me, please. Lovely, thank you very much. Right, we should have seen it's chemical store because it's in a battery, it's a food or a fuel that is being transferred electrically by the bulb to the bulb. The bulb is then going to transfer by heating and by radiation energy into my thermal store in the environment. An electric car will have a battery in it, the chemical store inside the battery, food, fuel batteries. It's going to be electrically transferred to a motor. From that motor, the motor is going to use forces to increase the kinetic store of the car, and by heating, increase the thermal store of the environment because motors get warm. The electric motor will have electrically transferred to it energy. Then the motor will use forces to increase the gravitational potential energy of the winch of the object because it's going upwards, and also it will increase by heating the thermal store of the surroundings. So please make sure we mark those in red and green pen. Anybody who didn't get at least 60% of that, I'd like an email just so I can do a little bit more explaining. And if it's all good, then it's all good. In a closed energy system, there can be transfer of energy, but not mass. There is no change to the total energy in the system. That means that if I have 100 joules of energy going in, I'm going to have 100 joules of energy coming out. All energy can be accounted for, even when energy stores change. The stores are changing, but they are not being created or destroyed. Energy is never created or destroyed. Some is used usefully, some is used wastefully. So if this is a light bulb here, this is a Sankey diagram, this is key stage 3, a bit of a reminder, the total amount of energy that's going in will always equal the useful energy added to the waste energy. Now, if you're not happy with Sankey diagrams, there will be a video going up onto my YouTube channel for my year 9s tomorrow, which will be the 20th of June. So if you'd like to, you can have a look at it then. And I'd recommend it if you don't. Nice and easy, just as a reminder of what we've been saying. We'll start with a store, there will be a transfer, we'll have another store. The only things that can transfer are forces like friction, work, gravity, electrical work, heating, which consists of radiation, conduction, and this is quite a useful little term, dissipation. Dissipation is when heat is lost to the surroundings in mechanical work, and usually as waste. So dissipation, keyword, we'll be stressing it quite a lot as we go through. Only ever put one of these transfers as a transfer in a diagram, okay? Gravitational potential energy, kinetic energy, chemical energy, thermal energy, they don't do anything. They just allow those transfers to do stuff. Okay, let's see if we can put this into a concept model. When a ball bounces, energy is transferred between different stores. The sentences below go into an energy flow diagram. Write one letter from the diagram next to each sentence to show where it goes. So each of these are out of order. Each of these sentences are out of order. Let's say 1, 2, 3, 4, and 5. I'll start you off with the first sentence. So we've got first sentence, it's going to go into A there, and it's actually this. That there is energy stored in the ball as it rises. It's called gravitational potential energy. So, no, that's a complete, it's this one here, pardon me. Energy stored in the ball before it drops, gravitational potential energy. That's the starter of it. So what's the next thing that's going to happen? After it drops, what's the ball going to do? So starting off here, what's the ball going to do next? Pause just for a couple of minutes to make sure everyone can get this. And if they can't, then skip forward and I'm going to go through the answer and I'll explain it. So energy is stored in the ball before it drops. It's here. And so it's going to start dropping. As it drops, it's going to be moving. So it's either going to be this one or this one as B, but it doesn't matter, they're the same thing. So I have my ball and now it's dropping. It's got kinetic energy as it drops. When it hits the ground, energy stored in the squashed ball as it hits the floor is elastic potential energy. So that's here. I've squished the ball, it's on the ground, but because it's bouncy, it's going to go back up again. Now, because it's moving after bouncing on the ground, D is going to be here, energy stored in the moving ball. And then energy stored in the ball as it rises is the last one. The ball's up here, it's getting gravitational potential energy transferred to it through the elastic, through the force of the bounce. That gives us our final letter here. Sorry for messing up the first one there. Didn't read it all properly. Okay, make sure we mark those in red and green pen, please. Okay, here's a get it, go for it. Down here, D, this is going to be an extended writing task. So I'm going to look for a paragraph. Okay, so I'll explain everything. Most cars use energy stored in petrol or diesel. 3 questions here about the way energy is stored, and then explain what happens to the energy stored in the moving car when the driver applies the brakes to stop the car. Use all the words in the box in your answer. Brakes work by squeezing together against the wheel to stop the wheel from turning around. And if the wheel isn't turning around anymore, then the car will stop. Now, friction is the force due to contact between 2 surfaces. So if you rub your hands together, then that's creating friction, which is a force which transfers energy. The go for it here is talking about that darned bouncy ball again. And we've got to quantify the amount of gravitational potential energy in that ball. Here's a scenario. The ball is dropped from 1 meter above the ground. At the top of its first bounce, it's 50 centimeters above the ground. How much energy is stored in the ball at the top of the first bounce compared with the energy stored in it just before it was dropped? And then maybe explain your answer. It tells you that it starts off at 1 and then goes to 50. What happens to the rest of the energy? And for extra challenge, I'm going to let you do that yourselves. You can pause that. Let's say about 10-15 minutes. And if everyone's done, then they can have a look at the knowledge organizer, or they can move on to the go for it. So if you finish the get it, you could try the go for it. And if you've done all the go for it, then have a look at the writing task there. All right, pause, please. All right, you should be done that. And here's the mark scheme for that work. This is just an example of what it might look like. Thank you very much. So we'll mark that work, and if needs be, there is an extension in the cover links. It is a Key Stage 3 lesson for Sankey diagrams, but hopefully it should be useful if we've gone through that in record time. And if not, that's absolutely fine. Send me an email if I can do anything to help. Bye-bye. Thank you very much, everybody.